Moving right along today to the last lesson of our area unit. We're continuing talking about the area of regular polygons. Today we're looking at different polygons though than we looked at last time, and you'll see why. So remember last time we figured out the formula for finding the area of a regular polygon. Remember it was area equals 1/2 AP. And just a friendly reminder, remember A was the apothem and P is the perimeter of the entire polygon. Now the three shapes that we did last time were triangles, squares, and we did hexagons. Now, I don't know if you noticed that, but those were the only ones that we really went into. And the reason that we only did these three shapes is because they made special right triangles when you were looking at the apothem and a radius. So in every example, we saw a 45, 45, 90 triangle or a 30, 60, 90 triangle. Okay, so that was last time. We had a lot of radical stuff going on. But realize that there are more regular polygons than just those three. For example, this shape right here, this is a picture of a regular pentagon. It has 1, 2, 3, 4, 5 sides. So we can have any regular shape given to us, and we can be asked to find the area. The process is fairly the same, so you still need to think about finding the central angles. So like the measure of angle XCZ, XCZ, is one full central angle, which should be the same no matter which two radii, I guess you should say, you're looking between. So remember we did 360 divided by how many sides or angles there would be, and that angle would be 72. All of those guys would. Now angle WCZ, or sorry, not W, YCZ, YCZ is this angle right here, which remember when they draw the apothem in, that cuts the 72 in half. So that angle would be 36 degrees. I'm going to go ahead and label that on my picture here. So that process is still the same. We also know on this picture the side length. And it's regular, so they're all 8. So we can go in and kind of think about finding the overall area. I could find the perimeter, because I have a side length. So let's say that, the perimeter. If each side is 8 and there are 5 sides, the perimeter would be 40 centimeters. Okay, so I have that part. The only thing I don't have for finding the area is I don't have the value of the apothem, and they even labeled it A here. So how do we find the other piece that we need? Well, we're going to have to use trig or SOHCAHTOA. That's the difference from yesterday to today. Instead of using special right triangle rules, we're going to use SOHCAHTOA. So here's our triangle. I need to find A right there. I'm going to redraw that green triangle down here just so it's a little clearer to see. We figured out that this top angle was 36. I want to find A. Realize that we also know YZ right here, the base of the triangle. The whole thing is 8, so I know that that piece is 4. It's half of a side. So what I'm going to do is I'm going to do SOHCAHTOA to get the value of A. Now go back, let's see, use the 36, you have the opposite and the adjacent piece. So you're going to use tangent for over A. Now they say what is the exact value of the missing piece. So remember when you plug this into your calculator when the number's on top, you do 4 divided by tan 36. So that's what I'm going to write here. that would be the exact value. Not necessarily 5.5. I mean, that's obviously rounded off. Here's my suggestion. When you go to find the overall area, I now have the apothem, so I'm ready to find the area. I'm just going to do 1/2 times this value that I get when I do 4 divided by tan 36 times my perimeter, which we knew was 40. So here's what I do, you guys. I leave that in there, so that way it's like I'm not rounding it. It's the exact same value. And I times that by 1/2, and I times that by 40. So rounded to the nearest tenth this time, that would be 110.1. And we're looking at centimeters squared. Okay. So a couple examples, actually only one for this type of problem. It says find the area of a regular octagon, so 8 sides, with a radius of 9, round to the nearest tenth. Okay, here's what I do. I kind of cheat a little bit, and no matter what the shape is, whether it's an octagon, decagon, pentagon, whatever, I just draw the bottom because I really only care about that triangle right there. So I kind of like cut the top half of the shape off. I kind of cheat, I know. Obviously that's not a regular octagon, but I don't really care. There's the center. That's the apothem. Here's each radius. So if you want to draw a full octagon, go crazy, but I just look at the bottom like part of the shape because all I really need is that triangle. So each radius is 9. And what else do I know? No, I don't know a whole lot else. I need to find the apothem and the perimeter. So I'm focusing on my triangle. And again, I'm just looking here. Okay, it's got 8 sides, keep that in mind. I need to find each central angle. So 360 divided by 8 would give me 45 degrees. When you draw the apothem in, you cut that in half, and it's 22.5, which is not the nicest number. That's my angle right here in my little right triangle that I'm focusing on. I need the apothem, and I need this half of the side right here. So maybe let's call this X, call this Y. All right, let's find the apothem first. So I have to do SOHCAHTOA twice, which this is gross. Now for Y, I have the adjacent and the hypotenuse. So I'm going to do the cosine of 22.5 equals Y over 9. And I'm going to do 9 times cosine 22.5. And I am going to round on this one, that's okay. I am going to use a few decimal places though. I'm going to cut it off after the 9, just so that way my answer is a little bit more accurate than had I rounded. So that's the apothem. Now I need to find X, so let's do X in 9, and let's do sine, opposite over hypotenuse. So 9 times sine 22.5. And that's 3.444. Okay, so this is 3.444. If I doubled that, that would be the length of a full side on my octagon, which would be 6.88. Realize to get the perimeter, I would have to multiply that by 8 sides. So the perimeter is 55.1 about. So let's put it all together. The area is 1/2 times the apothem was 8.3149 times my 55.1 here for my perimeter. So I'm going to keep that decimal in there and do times 8.3149 times 1/2. And my final answer, 229.1 feet squared. Whew, all right, on the back. This next formula, you guys, is going to seem a little disconnected from what we just did, but we're doing it now because it talks about area and it talks about trig. Those are the two topics for today. In this triangle below, you're only going to be told B, C, and the measure of angle A. Those are all the things in blue. Think about your formula for area of a triangle. I would do 1/2 times the base, which let's use B here, times the height, which they conveniently called H. Now, here would be the problem. So they're only going to give you what's in blue. So they're not going to give you the height on this picture. But we could find it. We could use trig to do so. So if you have everything in blue, let's kind of look at this little triangle right here. You have angle A, you have little c. You just need h. So you're going to do SOHCAHTOA over here. And guys, I'm just showing you where this formula comes from. So it would be the sine of A equals the height over the hypotenuse, which is c. You're going to be missing h, but you have a and c. So you would multiply by c, and the height would equal whatever the hypotenuse is times the sine of A. So here's what this formula has come up with. Instead of writing h, because we don't know h, they're going to substitute it with c times the sine of A, and that's where this weird, like, convenient formula comes from. Okay, so let's kind of rewrite it. This is a formula that is going to come in handy for you on these two problems at the bottom. So they're going to say 1/2 times b times c times the sine of A. This formula works, you guys, when you're given the information on a triangle in the order of side, angle, side. So I'm going to write a note. Use when given side, angle, side info in a triangle. Sounds weird. Here's how you use it, okay? So look at example 1. I'm given side, angle between, the other side. When I have the information organized like this, I can use this formula right here. This is so much easier than drawing in the height, using a little triangle to do SOHCAHTOA, major shortcut. All I'm going to do is 1/2. B and C are the two sides they give you, doesn't matter the order, times the sine of the angle, 76. And all I'm going to do is type that in my calculator all at once. And to the nearest hundredth, that's 2 decimal places. So I'm going to say 151.37 millimeters squared. Easy. Second example, look for your side, angle, side information. So here's the angle. The sides around that angle are these two. So you're not going to use this 16 at all. You want side, angle, side for this shortcut to work. So I do 1/2 times the two sides times the sine of the angle, and I just plug it into my calculator all at the same time. To the nearest hundredth, that'd be 70.42. So again, this last part seems a little disconnected, but we're talking about area, and it uses SOHCAHTOA, uses sine. It's very mathy, I know, but it's a major shortcut, which we love those.